Okay, we'll get started. So thanks everyone for joining. I can still see a few people arriving, so we'll get started anyway. Please, as usual, feel free to post any questions. Andy Barrow from our team is in the QA section, so drop any questions in there and we'll run through those. And let's have a quick look at the agenda. So yeah, hopefully we've got some good material for you today. What I'm going to do is step through basically an introduction to why PolyScale exists and what we see with regards to enterprise data gravity. Talk about why scaling data is hard and why does it get complex quite quickly. And then hopefully spend the most of this presentation actually hands-on with PolyScale. So showing you what it does, how it works, and then giving you some insight into the benefits and why it's valuable to use the product. I'm the founder of PolyScale, so my history is in big data and databases, and I'll be talking through sort of a lot of the experiences I've learned today to show you the benefits of what PolyScale can do. So one of the key things we often ask our prospects and customers is, why do you need to scale? And there's usually two sort of big buckets of that. One is kind of the emergency, something's on fire. Like my database is so busy, my reads are contending with my writes and performance is really suffering. And then the other sort of big bucket is what we're terming nowadays as kind of enterprise data gravity. So anyone who's not kind of familiar with that term, it's really the tendency for a large body of data to attract applications. So as your data sets get bigger and bigger and bigger, there's more and more interest around those and they become more useful and more teams want access to those. And the types of queries that's done on that data increase or change. And you find that actually starts to impact your agility to be able to move and manage that data. And that's really the term data gravity. And one thing I think that's been consistent through, the last 20 years I've been in sort of the data world is data is being created everywhere. And I can remember sort of talking about this many, many years ago. And it's, continues to accelerate. So things like 5G and IoT, massive amounts of data are being generated everywhere. And the usage patterns of that data change dramatically depending on what that data is and where it's required. And second point here, more applications and services start to use that data. So we've talked a little bit about this already, but it may be that a data set is designed to power a front-end application, for example. And from there's some interesting data coming in, and maybe a BI or analytics team now need to start looking at that data. And as the data sets get bigger and bigger, as I've mentioned, the ability to move that data becomes hard. So we think a lot about access to the data and where that physically lives, but we also need to think about privacy and compliance. So who can access that data? Is it highly available? And is there specific data policies that needed to be met with regards to data being in certain countries? How long can the data live for? All of these things are now key to how people store and manage data. And the last one here, global growth, is kind of a natural part of this, is where different, as enterprises grow, they bring on different teams and departments and people in different physical parts of the world. So how do you support offices and different systems as they grow to make sure they're meeting the same requirements? So at PolyScale, we think and talk about this concept of edge-first data, and really thinking about that with regards to who needs to access my data and where are they? And the whole idea of edge computing is we're putting stuff closer to our users. So how can we get that data as close to the users from day one? Like rather than that being an afterthought. I think many of us have worked on very large projects where the technical solution has driven that implementation. So I need a transactional database, or I need a columnist store, or I need a key value store. And then how you scale that to different regions and different locations and get that closer to your user base often comes as a secondary thought. So a lot of what we do at PolyScale is thinking around how do we get that data to that user as quick as possible. That's really our focus. Now, it's a fascinating world at the moment around being able to scale your content and code. So if you're thinking about, take the data tier out of the equation, and we're looking just to scale our content and our code, so our HTML, our images, our movies, as well as functional logic applications, there's a huge wealth of options available. So if you're looking to go multi-region, or if you're looking to just horizontally scale, there's a wealth of tools and services available. And certainly from our perspective, it's never been a richer ecosystem. So you can take any cloud provider, AWS, GCP, or whoever, and you can scale stuff into different regions. Using things like AWS Code Deploy, you can have this as part of your CI/CD and deploy into multi-regions as default. Now, some great companies emerging, or over the last sort of 5-7 years, Netlify and Vercel, who are really focused on lightweight JavaScript enablement and being able to deploy globally as default. So the idea of, like, as simple as a git commit, I can push everything out everywhere. That's a valuable proposition, and why would I not do that? And it's similar, and the CDN space is almost blending and merging with these sort of Jamstack companies. Things like Cloudflare with their workers option, where you can run serverless functions at the edge in dozens and dozens of locations around the planet. So again, if you can break off certain components or applications to run globally, why would you not do that? That's definitely a sort of an edge first approach. And then also another sort of key area here is containerization, and we're seeing companies like Fly and Section who are able to take entire applications and deploy those into multiple locations and do clever things around resourcing. So if you think about, how do I just scale my code? Maybe I've got a monolithic Java app, or maybe I've got a sort of a more lightweight Jamstack focused app. The options are very rich, and as I say, for deploying everywhere or minimally into sort of two, 3 regions. But the reason sort of PolyScale exists is, scaling stateful cloud native data is hard. And there's a couple of subtleties here for anyone who's not familiar, where, state is a hard thing to manage, but also doing that in a cloud native environment makes it a more complex and hard challenge. And, why is that? Well, it breaks down into a fair number of different areas, really. And, here's a quick summary, but latency, we've talked a bit about. Like, if I'm physically further away from whatever's serving my data, then I have to have that latency. There's not much you can do about that with regards to speed of light. So where is your data actually being processed and executed? If I'm making a database query and I'm in Australia and my server's in North America, I've got to have that inherent latency, plus the network hops and all of the different services that traffic goes through. Availability and reliability in SLAs. So it's not just a case of, well, let's go stand up another database somewhere else. What happens if that region goes down on my cloud provider? What happens, what SLA is my application tied to? And, are these processes defined and understood? Likewise, security, what data has actually been stored in that database? Is that data something that is, critical? Is it credit card information? Either way, its security has to be top of mind. Who can access that data? And is that in line with our, compliance policies? The cost is a very obvious one, but that breaks down into the 3 big areas in sort of cloud native environments are obviously your hardware, as in your server rental costs, bandwidth costs, what data is coming in and out of your environments, and then the people to manage these environments. So I talk a lot about PolyScale solving this problem without the cost and complexity. Now, the things that get really costly are obviously a complicated data system. So you need people to be able to manage those. Let's say, for example, you have a database read replica, and that replica comes out of sync. Who's actually going to resynchronize that data? You need someone with sort of a DBA background to be able to support that environment. So the costs go across not only your cloud environment, but also infrastructure and people inside your environment as well. Classic one is query performance. So let's say we have a database that's running slowly for a certain type of query. Why is that? We have to dive in and understand what's happening there. And then the sort of the key part of cloud that we've talked about already, unreliable hardware and networks. So if those regions do goes down, AWS had a DNS outage quite recently. GitHub have been having outages recently. What happens? What happens to your environment? Another one that ties into sort of all of these is kind of with regards to scaling is what happens when you have very large traffic spikes. So, we're having a busy part of the day and my e-commerce site is super busy. I'm doing a lot of transactions. Can I scale to support that? And perhaps a more interesting one as well is the concept of sort of ephemeral workloads. So if we think about what these companies are doing with regards to running functions at the edge, you could have a very large number of functions executing simultaneously. And how do you deal with those traffic workloads? So if I've got, say, 1,000 functions executing every second and then closing down, how do I manage the persistence layer to support that large number of connections? Compliance and governments, we touched on already. What countries, supporting which laws and compliance processes? Where is my data? Being able to understand that and audit it is a key part of this problem. And then, monitoring and alerting. So what happens when something does go down? Does that fit into my normal SLA policy? Have I got a team who can deal with those problems? And what's their workflow like? And can we integrate with that workflow? The consistency challenge is kind of one of the core ones. You think about cap theorem and, the classic case of is my state valid at different parts of different locations. So if somebody buys a product from my e-commerce application and somebody tries to buy that exact same product, half a second later, what happens? Will that data set be consistent, or am I going to be eventually consistent? Sharding and storage. So a classic one we see a lot of is what data do I store where? If you think about, let's say, a gaming network, for example, or a gaming company may have a large leaderboard of top players in a certain game, and working out sort of how and where to shard that data is kind of a hard challenge, because everyone in every country wants to see what that leaderboard looks like. So, where do we store that data? Do we start sharding that data by a specific key? And many companies end up just putting all data everywhere, which then ends up introducing all sorts of other complexities and costs around network traffic and being able to keep up simply with the update workloads. And the last one we've touched on already, but really expertise and skill sets. So, when you start to scale these systems, what is it that you need from your team? How long is that going to take? Should people be spending time accelerating your data versus building product or rolling out new features? So what are the options for scaling the data? And there are many. So I don't think there's a single sort of bucket you can put these things into. And I've just pulled out 4 here to chat to very briefly. One of the ones we see a lot of is, look, if I need to make something go faster, I can scale the application tier. So I'm going to run something like Redis, and I'm going to write code to work out what to cache, how long to cache for, and I'm going to do that in each of my applications that I roll out. Very efficient, very fast, but there is a cost and complexity there of having to write code. And that's sort of magnified when you think about environments that there are multiple departments. Let's take an example like Zillow, or any sort of real estate website whereby there may be 5, 10, 15 different repositories of data there, providing a single view of a web page or a single property. And each of those may have a different caching policy. So you can see there's a large cost on an enterprise for implementing sort of caching at the app layer. The other one, we talk a lot about is database read replicas. So the ability to, let's say we have a single node database that's running on the East Coast of the US, and we're now started to see customer traction in Europe, where you can deploy a read replica into that region. So we have a read-only copy of our data that can then be queried because that's closer to our users. That's going to give us faster response times, and it's also moving that read workload, some of that read workload, onto a different area. And again, there could be cost and complexity there with regards to within my web application, I now have to work out my logic and split my logic for reads versus writes. So if I'm writing to the database, I send it to the origin. If I'm reading and I'm in this specific area or region, then I'll hit my read replica. So there's lots of, moving on to database migration, there's lots of incredible database products on the market nowadays, from, highly scalable key value stores at the edge, global databases, things like Cockroach and Fauna and Yugabyte, that are designed to keep your ACID compliance across regions. So, lots of times, an option is to move to a different database. If there are features that you're not seeing, or you can't scale, or you've really reached the limits of your scaling abilities, your option is to let's buy a bigger boat, right? What are we going to do? Something has to change. And again, another valuable option, right? So it's then a case of going through that process of how do we migrate? If you've got a large e-commerce application, taking that data set and moving it to a new database is a big project. Does the query language work as it does today? What features do we need? What are we missing? And this goes right through transactional databases, but also analytical and everything above. And then finally, lots of enterprises I've worked with end up in sort of that polyglot data tier, whereby they're splitting out certain features and scaling those independently. So we're seeing a big trend of sort of monoliths moving to microservices, whereby let's take our slowest running feature on our web application or whatever it may be, a BI tool, and let's scale that one independently. So for example, you might move that out to a serverless function that runs on Lambda or any other tool. You may implement caching specifically for that feature. You may even break off that data into a separate repository, into a separate data store. So maybe it makes sense to run that on Redis. And then you have the challenge of synchronizing that data. So how do I keep my data synchronized across these different platforms and services? And a common technique there is to use things like change data capture streams. So capture events that come in from your database, drop those into things like a Kafka stream, and then you can distribute those throughout the enterprise and across region as well. Anyway, final statement there at the bottom is all of these are valid, right? These are all great solutions. This is what people do today. They all have costs and complexity, but that's the nature of the beast that we're dealing with. So on to PolyScale. So just to touch briefly on kind of what we do and how it works, and then we'll just dive into a demo and get hands-on. So we think about data as global and serverless. So, I've talked a bit about sort of edge-first thinking and why you would want to think about your data being multi-region from day one. And most people don't or can't, because it's a hard thing to do, unless you're in that situation where you're starting a brand new, fresh implementation, and then you can start architecting that from day one. So PolyScale is a no-code database edge cache, and it distributes your data and query compute closer to the user. So there's quite a bit there. Let's unpack that a little bit. So firstly, PolyScale is no code. So really the core of everything that we do is how simple can we make this for a developer or an architect to implement? How easy can we make this to distribute your data globally, but without writing code, without deploying servers, without managing and maintaining stuff, without worrying about that sort of cost when I hit traffic spikes. So how simple can we make that? And you'll see that right throughout the product. And the core of what we do is we're a caching service. We're a database edge cache service. So what we do is we take pieces of your database, we store that in the regions that make sense to where the demand is, and we store that for a short or long period of time, depending on the rate of change of that data. So our proposition here is that caching your data closer to the user gives you that performance and gives you that scale to take your data systems, where they need to be. And then the core part of here is that we not only distribute the data, we physically put that closer, but we also distribute the query compute. So when I run a SQL query, that actually executes on a PolyScale point of presence or a POP, rather than actually executing on your database. So the actual workload of running those queries runs on your runs off of your database and runs on PolyScale. And as I've said already, sort of our mission is really to enable edge-first data without cost and complexity. So really focusing on making it trivial to scale this data globally. So let's do a quick demo. And I'm going to dive into what we call playground.polyscale.ai. And if we hit the website here, let me just, you'll see that there's a live demo on the front here, and this opens up playground.polyscale.ai. Excuse me. And this is a live web application designed to demonstrate the performance of PolyScale. And it's a live, as I say, it's a real web application. It sits outside of PolyScale's networking environment, so it's very customer focused and realistic. Now, what we have is a public MySQL instance. So you can connect into this with any MySQL tool, and you can have a browse around. There's a sample schema and some data in there, and that lives in a database sitting in Europe. And it's a very small database that's under some load. And then we have this application, the Playground application, lives out on the US East Coast. And you can see here we've got 3 steps to run through this process. And our first step is just to query the database directly. And the idea of this is it's demonstrating how a US customer might access a website that's being run out of Europe. It's kind of as simple as that. And if I click the Start Queries button, what happens is for 20 seconds, we'll run SQL queries against that database sequentially as fast as possible, and we time the execution of each of these. And then up here, you can see that we have an average response time. And this query is not particularly complex. We can browse down here and have a look at that SQL query. And all that we're doing is we're sending these as fast as possible sequentially, and we're changing the department name. So you can see we've got a basic join, and there's a various bunch of departments going in there. So pretty basic stuff. Now, going back to that sort of no-code focus, the only things we need to do to introduce PolyScale or to start routing our data through PolyScale is to update the database hostname and update the database username. So these are typically in environment variables, or they're a configuration file. Once you've updated these, so here we've updated to mysql.polyscale.global, all the traffic will route to the closest PolyScale point of presence. So it automatically decides, okay, I'm on the East Coast, I'm going to pick up the closest POP for PolyScale and run my traffic through there. So if I click this, we'll make a new connection through PolyScale, and we do the same thing, we run the same queries. But what you'll see now is that PolyScale inspects that data, and it works out what are the reads that it can cache, and it then serves those from the point of presence, which is obviously much, much faster than going back to the origin database. And you can see that every query there, we're rounding, so it's coming back in less than 0 milliseconds or 1 millisecond. And we did, in that 20 seconds direct, we did 64, and with PolyScale, we did just under 30,000. So hopefully that's a good representation of kind of what we do as a company, right? We make it super easy and trivial to implement. And then we look at that data, we inspect that data, and we say, okay, what data can be cached? What are the reads? What are the selects and the shows? And then we serve those from PolyScale rather than serving them from the origin database. So before we sort of dig in a bit deeper, PolyScale really solves 2 problems. And we've talked about these already at a high level, but regional latency is that classic what we've just seen. Something's in a different region. I'm paying the price for that sort of network hop, that speed of light latency, but I'm also paying the price for making TCP connections and going back and actually executing database queries. Like, that has some overhead. So all of that can be moved onto the PolyScale side, which moves those reads much faster, makes them much faster to the user. And then the other one is sort of the read query performance. So we see often where people will come to us and say, hey, my database is performing really badly because it's just so busy. We've reached the end of how we can scale. We've added read replicas, but they can't keep up because there's too much traffic coming through. Or we're just running out of CPU. And a classic approach to this is to separate out your reads and your writes. So if you offset that workload from your database, do it somewhere else, that's a classic way that you can scale your environments further. And that's exactly, that's a good use for PolyScale. So last slide before we sort of dig into the product in a lot more detail, but it's, how does this thing work? And there's three sort of core components that make up PolyScale, three big components. Starting in sort of the right-hand side here, we have a network of points of presence all around the planet. Now, to get your latencies really, really low, like I'm talking sort of 1 millisecond or less, PolyScale should be as close as possible to your app server. It's a sidecar cache to your application server. So if you're scaling to a new region, you just deploy that app to that region using one of the amazing tools that we talked about earlier, or networks and services. PolyScale can be in any network, so we can deploy into any location. And we're building out this network based on customer demand. So we're pushing this into different clouds and different regions based on where it's needed. Where are we seeing that latency that needs fixing? As I said before, using the domain polyscale.global will always resolve to your closest point of presence. So that's not something you have to think about, but that's how you're going to get fast, is by keeping that latency low. And then the core of what we do are these sort of two components, the left-hand side, the AI managed cache, and the native database protocols. And if you think about what we're doing here, PolyScale actually inspects your native database wire protocols to work out what can be cached, what is a read, what is a write. So if I have inserts, updates, and deletes, manipulation queries going on, those get pushed through to your origin database. Now, the great thing about that is nothing changes with your current environment. So you don't have to change your query language. You don't have to change your consistency, your transactionality. Nothing changes. All of your writes get passed through and processed in your central repository as normal. It's just the reads that are going to get cached and served from PolyScale if appropriate. And what I mean by if appropriate is that if you think about, let's say we have an e-commerce application that I keep going back to, and let's say that does 10,000 unique SQL queries that run through the platform. Which one of those, or which of those should you cache, and how long should you cache those for, and where should you cache those? Those are three hard problems for humans to solve. So you're getting huge workloads of data. Should I be caching this data for 10 hours or 10 seconds? It's very hard to answer that. If you're in a much more simplistic environment where maybe you've got one microservice and you as the developer know, hey, I want to cache that for 10 minutes, then great. That's something you can configure. But more often than not, you have these situations where you have complex workloads that can include things like session tables that you don't want to cache, security-based tables that are complex to get around, your head around what should I cache and for how long. And that's really where our AI managed caching comes in. So PolyScale continuously inspects every single unique SQL query that comes through the platform and builds a model around that to decide how often should we cache that, when should we expire that from the cache. And we do that using a whole number of inputs, things like query arrival rates, like how often are people requesting it? How often is that data changing when we see it coming back from the database as a cache miss? So there's a whole bunch of inputs that go into these models to decide, do we keep that data and how long for? And what we'll be doing there is moving the time to live, or how long that is persisted, up and down accordingly. So, if we think that data is changing, we'll be reducing that time to live. And if we think it's not changing, we'll be increasing it to get you better hit rates. So that's a quick summary of sort of the core building blocks of what we do. And as I've said already, we sort of obsess about abstracting complexity from developers. And if you think about sort of that developer experience on the top line here, as you've seen, you can integrate this in minutes. It's literally trivial to implement. And the reason we can do that is because we're that no-code approach. We're completely transparent to database clients. So we've touched on this already, but think about my web application. Maybe that's using an ORM. Maybe that's written in TypeScript or Java or whatever it may be. Nothing changes there. It's wire protocol compatible. Likewise, maybe I'm using Tableau or ClickTech or any BI tools. I can just connect through PolyScale, start caching that data rather than hitting those origin databases. So as we've been talking about the AI side of things, full automation of what to cache and when not to cache is really critical to what we do. As you'll see when we dive into the product in a second, you'll see that we also recommend what are those queries that are candidates to cache. What are the ones that are have very low cardinality and are good candidates to be caching for a long period of time? And then another key part of this is we've talked a little bit about how long do we sort of keep this data for. One of the great features of the platform is that if we see some data being updated, so if PolyScale sees an insert, an update, or a delete coming through, it will automatically blow away that data from the cache globally in a few milliseconds. So it automatically makes sure that your next read on that data will be fresh and will be real. It's coming back from the source database rather than getting a hit from the cache, which you may not want. And again, that's configurable. You can turn off the smart invalidation if that's something you don't want. And then finally, something that we've got coming soon is kind of the ability to warm that cache. If you take a step back and think about caching, the hard things are, when do I invalidate and when do I, warm the cache? How do I prevent those misses? And a great use case here is that I think we all see every day of the week is you're logging into some sort of personalized service. So for me, I log into my AT&T account, I look at my cell phone bill, and it's horrendously slow without picking on AT&T. So, these types of things are personalized environment because it's going back to a database, it's loading that data just for me, it's calculating my bills and my usage history. And what PolyScale's going to be doing is looking and inspecting those clusters of queries. And we know that the user is likely to go and execute those. So we can preload those into the cache to give them a super fast experience. And it's exactly the same with your Netflix account or iTunes or whatever it may be. You're logging into your airline, you've made a booking. Well, that should be extremely fast and preloaded for us. So that's an exciting feature set that we'll be releasing soon. And then finally, again, from a developer perspective, being able to scale this globally shouldn't be something I care about. Okay, I'm getting a lot of traffic from from Mumbai in India. Well, great. Let's just be able to service that without waking anyone up and deploying servers. So our edge compute, we can happily, easily serve any cached query in less than a millisecond at scale. So thousands of concurrent queries. We have connection pooling being released soon that allows you to have very, very large numbers of connections on your, hitting PolyScale, and then keep and maintain a very small number of connections going through to that origin database. So we can be clever around that traffic shaping and how we actually deal with those fast lift connections. And that goes back to what I talked about earlier, which was people being able to run functions as a service through, Netlify and Cloudflare and Fastly, very fast ephemeral functions. And then finally, we have a serverless SaaS environment whereby you can just sign up, as I'll show you in a couple of minutes, get started, throw your data in there. And we also have a self-hosted option whereby you can actually take the PolyScale POP, the point of presence that stores the data, and embed that inside your own infrastructure and deploy those where you need them to be. And that anonymously connects back to our control plane for the caching and the actual cache management. So if you want to live in an environment where you can't put your data in somebody else's cloud or network, that's definitely something we can support, as well as things like private VPCs and private networking, fully managed. Okay, so the final section here, let's just dig in and have a look at the product. So we've done a quick demo with the playground. What I'm going to do is I'm going to create a brand new account here. So I'm just going to click this continue with GitHub. And what that will do is it will create me a brand new PolyScale account, sign me in and bootstrap a couple of things that are useful for kind of onboarding. Now, you can see here what it's done is it's actually created me a demo cache, which we'll talk about in a few minutes. But if I was coming to PolyScale and said, hey, I've got my database that lives here and I just want to get started, what do I do? Now, you just click the new cache button, and you'll see here that we ask for your type of database. So we have MySQL and MariaDB and Postgres supported today, and Microsoft SQL Server coming soon, and a whole bunch of others. And the only things we need are the host name and the port. So we're not storing your database username and password, which is nice from a security perspective. And you can also see here that I can put PolyScale into a non-caching mode. And we see this a lot in kind of pilot environments whereby PolyScale will actually, as you'll see in a moment, tell you how much time and traffic you can save using the platform without actually caching anything. So it kind of goes into this observability mode whereby just tell me what I could save rather than actually caching, which is a nice feature. So you can just turn this on and off if you want to. And then the final option you have is, do I just want to automatically cache everything? Let the machine do it, or do I want to do everything manually? So if everything as default is uncached and I can come and set those manually, that's another option that I can do. So to get started, that's all you need. And once a cache is created, it will give you back, if I move over to this settings tab, a set of connection details. So you can see here, like this MySQL instance, I just update my host name and I update my username, my database username, which is a concatenation of one given to you by PolyScale and your real database username. And the reason we can see the real database username here is because this is the demo cache that the playground uses. So this is a public database to play with. So it's as simple as that to get started. And if I run this sample queries over here, this takes us back to the playground, and I'll just get this started. We'll run some data through here, and then we'll take a look at what PolyScale actually shows us and how we can observe what's happening. So we'll let that run. So that's the direct traffic, so we won't see anything through the platform there. And now we'll connect through PolyScale. Now, the nice thing about, just while that's running, the nice thing about, or the differences factor, if you create an account and click the Run Sample Queries button, it actually links to the playground here using your unique cache. And that gives you the ability then to observe what's happening. So I can come into this now and everything's linked into this cache because I've clicked this button here. So first of all, we get kind of a summary, a summary here. And if we go back, we can see we ran 16,000 queries, and that actually saved me 1 hour and 42 minutes of execution time on my database in that those 16,000 queries, because those are being executed from PolyScale. We know how long the cache miss took because we had one of those to start with. We measure that, and then we can calculate easily what sort of savings we're getting. And you can also see here, in this case, I'm just accessing this from a US point of presence, and any other countries would be listed here. Now, if we drop into our observability tab, you'll see some useful stuff here. And this is, again, where we really focus on abstracting away that complexity and making it simple to understand what's happening. And yet, if you want to go into the detail, you have that option as well. So this view is all about show me the specifics of what's happening with my database. And there's been so many customers and prospects we've talked to who turn this thing on and then find huge bugs with their code. For example, we had one customer who was running an accidental loop of every time a page loaded on their website, it executed 600 duplicate SQL queries that actually executed. Those things pop out very easily through this type of view. So if we look at this in a bit more detail, one of the core concepts of PolyScale is that we have this idea of query templates. So the query that we were using for the playground, as we talked about, we were changing that department name. So if you remember the query down here, we were changing that department name, and there's actually 9 of those that come through. So what we do is we abstract that into a couple of things. We remove any parameters to start with. So that gives us a completely PII free, we're not saving anyone's personal data inside of our metrics environment. So we remove any parameters so that the user can still identify what that query looks like, but we're not passing through credit card numbers and telephone numbers, et cetera, et cetera. So everything's anonymized. And the second thing is, once we've anonymized those, we clump those or group those queries together into what we call a query template. So although these queries are semantically different, there's 9 different ones, we display them in the UI as a single value, as a single query template. And that's a nice way to think about the data, where if you had 10,000 unique SQL queries, you may only have 20 types of queries or query templates. And if we dig into this a bit further, we can see that we ran 16,000 of those. There's a mode. Are we running this manually, or are we using the AI to actually manage it? And then we also provide a cacheability score. So we can see here, this is a highly cacheable query. And then efficiency, how efficient is it actually running? What sort of throughput am I getting? And as I've talked about, we're sort of abstracting that complexity. You can also drop into the details view. And that takes you down into the lot lower level of detail, where we break things up into the query template, the queries themselves, how many hits and misses and invalidations, and how many unique queries did we get in that template? What was the size of the payloads? How efficiently is the cache running? Total execution time. So, how much time are we saving you by serving this stuff from the cache versus, letting it go through? So you can really dig down into all of that detail. Now, the other side of this as well is you can view this in different ways. Maybe I want to look at this by time. Maybe I want to look at it just by query template. And we only have one here, which is nice. But this throws out the queries that are super busy. What are the ones that we're using all the time? It's a nice way to view the data. So what I'm going to do is two final things before we wrap up. One is I'm going to just show you how easy it is to connect. So I can, take these connection details. We've got a user here. I'm going to copy that. I'm going to open up my MySQL Workbench tool in this example, and I've set up just a standard. It's just a standard MySQL tool here, and I'm going to drop in my username. I've already put the MySQL.polyscale.global in, so nothing's different, and I'm accessing the the employee schema. So any tools that you're using. Playground is the password for this public database, as we've talked about. Any database we're connecting to, just use your native tools. And once I'm using my native tools, all of that stuff becomes observable. So if we go back to our observability tab, you can see now a whole bunch of queries just came through, which were generated by MySQL Workbench doing its thing as it finds its way around and sets up your environment. So you get to view every type of query that comes through the platform, however small it is. As default, we hide what we call DQL is what we show. We hide the DML, the manipulation queries, the inserts, updates, and deletes, because those aren't cacheable. But equally, I can just come in and turn those on. So then I can see, I can see here anything that was actually manipulating the data. This is a use statement. This one is a set statement. So things that are actually manipulating the data, we can see as well. So you get that full breadth of everything. So yeah, just wanted to show you, as natively browse around, use any tools that you want to, nothing changes, run a couple of queries, and we'll see those immediately become observable, which is nice. Okay, so last thing I wanted to do is just show you how that AI works. Like, how do we analyze a query and decide, yeah, we should cache that or we don't? And let me show you that in action. So in order to do that, in this demo cache that we bootstrap, we set some rules so everything's cached for you, ready to go to give you a super good experience. I'm going to come in here, and firstly, I'm going to delete these rules. So I'm going to delete any manual rules that I have set, and I've got my cache then set to use the auto caching. So I'm going to delete my rules that we set up as a demo. Let's do that. Now, once that's done, basically everything's in kind of auto mode. So you'll see here that all my queries now are in auto mode, and the machine learning is tracking that. And that's the default behavior unless you turn that off. So what I want to do is, let's grab that connection detail again, and I'm going to open up a bit of code. And what I've got here is, in this example, just a bit of JavaScript. You can see here I'm making a connection to, let's drop my username in, and I'm going to copy that host name as well. So I'm connecting to PolyScale, and this is using the playground demo database again. And all this code does is just does a loop, and it fires off a SQL query. And this SQL query says select count star as F, and then give me the average salary from the salaries table. And then we just log out how long does that take to run. And so let's just kick that off. So let's run that script. And oh, interesting. What have I connected to there? Good live demo. MySQL to PolyScale global. That's interesting. Why not save that? That's better. I think I didn't save that. So but you can see here, so query's being executed in 2 seconds as we're making the initial TCP connection, about a second from my home machine here, my bandwidth, connecting to whatever POP I'm on. And you can see here it gets around a second. And then on query 13, we suddenly get a response time of 39 milliseconds. And what's happening there is that the machine learning is inspecting that query pattern. It's building up confidence and saying, right, we're not seeing anything change in the database. We can see the same query coming in. Its arrival rate is consistent. So we're seeing it, one after the other. And okay, we're confident we can start increasing that time to live. And that's where, once it's cached, we get a cache hit, and then we get the cache responses back. So that's an example of taking a unique query and throwing that at PolyScale without doing anything, and it automatically caching that data for you. And of course, we can see that bubble through in the observability. There it is there. So we did 50 queries, and let's have a quick look at the details on that. We did 50 queries on that, 37 hits, 13 misses, and 74% hit rate. So, and that will build up and up and up depending on what you're doing with that data. So hopefully that's a good demonstration. Now, the other really nice thing is that if you're sending in a query that is similar, so perhaps it's got a different query parameter, the machine learning learns from other queries in that data set. So if you think about the one we did for the playground, the fact that these departments are changing, the machine learning builds up state about each of those, but it also combines them at the template level so that when we see the next one of those, we can start with a built state. We're not starting from nothing or empty. So the rate that we can increase the cache and start caching stuff is much, much higher. Okay, so just to round up, I know we're sort of 9 minutes from time, but just to round up, let's just drop back to a couple of slides, like how can you get started? How can you have a play? I mean, basically, you can run through exactly what I did there, create a new cache. I'm just going to jump through these slides, how to connect. There is a live repository of a starter app. If you're TypeScript or Node.js, we're using Node and Next.js and Prisma to build a starter app, and you can take that here. You can see it's a properties app, and what this does is it runs some real database queries in the background to build pages around. You can see there's lots of real estate metrics that come through here, and there is also an accompanying blog article that goes hand in hand with this. So if you hit the blog, you'll see that there is a Next.js and Prisma blog here. And this talks about using this application, how we deployed it to a couple of locations. We benchmarked it, got some results, and the sort of performance increases you can expect for this type of application. So feel free to jump in and get hands-on with that to get playing with the platform. And then finally, we are hiring. So we're hiring across the board. There's a few more roles that aren't actually listed here as well, but do get in touch if this type of work looks interesting. We obsess about data and latencies, and if that excites you, then definitely get in touch.